Hi, my name is Jamie DeYoung. I created this video about proving properties of logarithms for the course MAT135 at the University of Toronto. By the end of this video, you should be able to use properties of the exponential function to determine properties of the natural logarithm. These skills are applicable to other powers and other logarithms, but for the purposes of this video, we'll just be looking at the specific example of the exponential and natural logarithm functions. So the first question is, what do we actually know about the exponential function? We'd like to determine some properties of logarithms, but first of all, we need some tools for that. So the key point and the reason that we're interested in the exponential function is that the exponential function and the natural logarithm are inverses. So if you know that the exponential of a is b, then that is equivalent to saying a is the natural log of b. But we also know some other properties of exponential functions that will be helpful here. For example, 1 divided by e to the power of a is the same as e to the negative a. If you multiply two exponentials, that is the same as taking the exponential of the sum of those values. If you divide, and then analogously you get the difference. That's just applying the previous two properties. And if you have e to the power of a to the power of b, this is just the same as e to the power of the product of a and b. So these are some of the key properties we know about exponentials, and some of them will be useful in the exercises that we do here with determining properties of logarithms. So the example that we're going to look at for this video is specifically the natural logarithm of ab equals the natural logarithm of a plus the natural logarithm of b. So this is a property that you may have come across before, but we'd like to prove it specifically using the properties we know already about exponential functions. So what we have here is an equation regarding natural logarithms, and most of the properties that we've already seen involve only exponential functions. The key property that we do have that involves logarithms at this point is that the exponential function and the natural logarithm are inverses. So e to the power of the natural log of ab. So this is just taking the exponential of the left-hand side. Now, we know that since these functions are inverses, this cancels out to just give ab. What about the right-hand side? Well, the right-hand side seems a little bit more complicated. E to the power of the natural log of a plus the natural log of b. But we had a property that we saw on the previous page that dealt with the exponential of a sum, and that told us that we get e to the power of logarithm of a multiplied by e to the power of the natural log of b. So this is just applying the property from the previous page. And now, well, once again, we know that the exponential and logarithm cancel out. So e to the power of the natural log of a is simply a, and e to the power of the natural log of b is b. So what does this tell us? Well, we know that if we take the exponential of both sides of this equation, we get the same thing. Now, that doesn't immediately make it clear that the two powers have to be the same thing, because, well, we don't actually know what this looks like necessarily. But actually we do. We know that the exponential and the logarithm function are inverses. And one of the things that we know about having an inverse is that it means the function is one-to-one. What does that tell us? Well, it tells us that if e to the power x equals e to the power y, then x equals y. That's what it means to be 1 to 1. So, because e to the x and the natural log are inverses, we know it's 1 to 1. And before, we calculated that e to the power of the natural log of AB is the same as e to the power of the natural log of A plus the natural log of B. And so we can conclude that the natural log of AB is equal to the natural log of A plus the natural log of B. So we have shown this using the fact that the exponential function and the natural logarithm are inverses, and using a property that we already know for exponential functions. And we can do that for other properties of natural logarithms as well. So I'm going to leave you with an exercise to use the properties of exponential functions to show that the natural log of a to the power r is equal to r times the natural log of a. So you can use similar techniques and have another look at what properties of exponential functions we have that might help you with showing this property for logarithms. Thank you.